Guys, good morning. So you'll notice that all the desks are moved to the side because you're going to be doing more of an interactive activity today, dealing with the law of conservation of mass, using chemical reactions such as photosynthesis. Now, a little bit when we talked last week about photosynthesis, it is a chemical reaction that has a certain amount of carbon dioxide, water, glucose, and oxygen, as we saw from our word wall. So if we kind of like go over some of what our vocabs were, front-loading this unit, we have photosynthesis, we have law of conservation of mass, carbon dioxide, chlorophyll, oxygen, chloroplasts, sugar, glucose, chemical reaction, coefficient, and subscript. Now, some of you guys may have been under the confusion of the difference between coefficient and subscript, so hopefully this clarifies it a little bit. So our coefficient was our big number in the left side, and our subscript was our little number that's always sub beneath the atom it's referring to, so it is the smaller number. So our coefficient deals with the entire molecule, subscript only dealing with the atom. We're going to distribute the coefficient each time in order, in this case, to get 3 times 2 hydrogen, 6, and 3 times 1 oxygen, so we'd have 3 oxygen. So that could kind of help you guide along when you're constructing these. You're going to use these counters today. Blue for hydrogen, red for oxygen, and green for carbon, in order to drive and form your own model of these reactions. First, you're going to start off and form your molecules for the reactant side, meaning the before part of the reaction, with carbon dioxide and water, forming 6 of each. Then, once you've shown me that, you're going to take the same groups, and you're going to form the product side, glucose and oxygen, using your materials. Now, you'll only reach into your extra bag of materials as soon as you run out of these. I want to know exactly which ones you run out of and which ones you don't, that you have left over. So make sure you don't change the number. All right, so as we go through this, our standard again to cover, we're going to know how to understand the law of conservation of mass through this reaction. So let's go ahead and try this out. All right, so what do we have from our reaction? We have our modeled out, great guys, 6 H2O molecules, 6 carbon dioxide CO2 with energy added to form 1 glucose C6H12O6 and 6 oxygen molecules, O2. Now, we talked a little bit about this earlier. We formed from our KWL chart. We had said that what did we already know? We already knew that photosynthesis involved plants and that it was a chemical reaction. And also, as far as what you guys wanted to learn, looking at the chart over here, we wanted to learn, one of you guys said that we wanted to learn, why did plants have sugar, was one big concern. Why do plants have sugar? All right, so what did you guys learn from this demonstration? What did you learn? Over here, Tracy?
The amount of atoms doesn't change.
Right, the amount, so I'm just going to abbreviate here, of atoms does not change. Okay, so when something doesn't change and it stays the same from one side to the other, even if it's been configured differently, it's called being conserved. And that stands in for our law of conservation of mass. What it's saying is that the mass and weight of every single atom we have on both sides stays the same on both ends of the reaction, what we start with and what we begin with. And if we look at it, how many oxygen molecules did we have from the beginning? 18. 12 hydrogen and 6 carbon. Did we have the same on the end? We sure did. When we laid it all out, we saw that we had the same in the beginning and the end. They just were configured differently. So thank you guys for an excellent demonstration.